Hi, I'm going to do a video for section 8.3. I'm going to talk through some of the problems in there. And you've been asked to do problems 1 or 2, 3 or 4, problem 5, and then problems 8, 9, or 10, 8, 9, or 10, and problem 14. So, let me go back to 14. Okay, so let's take a look at these problems. So number 1 gives you some information. We're trying to prove these triangles are similar in most cases, or using their similarity to prove something about the ratios of sides, right, or angle measurements. So angle A here is congruent to angle D. So that's a good start. We got one angle. And then it says angle 2 is congruent to angle 4. But those are exterior angles, if you remember from chapter 7, or if you've haven't gotten there. Exterior angles are angles that are outside. If you extend a side beyond the vertex for a polygon, you'll get an external angle. But the nice thing is that line DE and line AB both make straight angles. And so if angle 4 and angle 2 are congruent, then their supplementary angles 1 and 3 are also congruent. So now we have two angles. So angle gets us where we need to go. And number 2, we want to draw a triangle, GJK, with HM being parallel to JK. So H is going to be a point on GJ, and M is going to be a point on GK. So what the heck does that all mean? So let's draw a triangle. Let's draw a triangle, and then we can see what all that means. So I'm just going to call this G, J, K. Okay, I've drawn that. And we're going to draw HM is going to be parallel to JK. Okay, well, H is going to be a point on GJ. So let's put it here. There's H. Okay, and we're making a line that's parallel to this one, flump and flump. And we want M to be on GK. So there's M. Okay, what we want to prove is that GHM is similar to GJK. Well, because these are parallel, it's pretty easy to say that these two angles are congruent and these two angles are congruent. Okay, so then you've got angle. Okay, now let's take a look at 3 and 4. I'm going to pause and erase some stuff. And I am back. I have erased things. So now let's look at 3 and 4. We've got NPRV as a parallelogram, and we want to prove that NWO and SWT are going to be similar. Okay, it's not going to be terribly hard to do because NP and VR are parallel, and so that angle and that angle are congruent by pairs of alternate interior angles. This angle and this angle are congruent by pairs of alternate interior angles because OT is a transversal for the two parallel sides, and NS is a transversal. And we can go ahead if we want to overkill it. This angle and this angle are vertical angles. So you got angle. As soon as you got two angles, you've got it, though. You don't have to go all the way to angle. And the number 4, we've got AC is congruent to AE, which is telling us that ACE is an isosceles triangle. We've also got CBD is congruent to EFD. All right, so we can say very quickly that this angle, we'll be able to prove that these angles are congruent based upon it being an isosceles triangle, and we've been given that this angle and this angle are congruent, so you've got angle, and that'll do the job for that as well. Number 5, Tvpx is a trapezoid. Okay. Now, obviously, I'm giving you some hints, and almost there. You have to write the proofs for these, of course. So Tvpx is a trapezoid. bases are TV and XP, which means when we define the bases, that means we've told you that they're parallel. So this is parallel to this. That's what that tells you, which is going to open up some transversal stuff. So we are going to try and prove that TVY and PXY are similar triangles. And it's not too hard to prove once we've got TV is parallel to XP, because TP is a transversal and XV is a transversal. You can easily get three angles. You can easily get angle, angle, angle. This is going to set up a vertical angle, so that's kind of a gimme already. So I really just need this and one more pair of alternate interior angles, and you are good to go with that one. I'm going to pause and erase. I have erased things, and now I will go on to deal with numbers 8, 9, and 10. So let's do that. So you get a choice of 8, 9, or 10. So we've got given SP is an altitude to NR, and RT is an altitude to NS. So we want to conclude that triangle NRT and NSP are similar. This is going to be fairly straightforward to do because we've just established right angle here and a right angle here, because those are altitudes. And they both share angle N. So you got two angles, and you are good to go for similarity when you've got two angles congruent. Now, if we prove that an acute angle to one right triangle is congruent to an acute angle for another right angle, then the triangles are similar. Well, if they're both right angles, you've already got one angle. And then the acute angles are not the right angles. So if we've been told that one of the angles that are acute is congruent to an angle that's acute on the other one, then you've got angle, angle. So you're good to go with that as well. And if the vertex angle of one isosceles triangle is congruent to the vertex angle of another one, so here's my isosceles triangles, okay, and they are different sizes, but if I know that this vertex angle is the same for both of them, well, the two base angles, so here's my base. My bases are different sizes, but there we go. My two base angles are congruent to each other here, and they're congruent to each other here. Well, we got whatever's left from 180 divided here and here. So by division, you can prove very easily that the base angles will be congruent as well if the vertex angle is congruent. And so you'll have angle, angle, angle immediately, and you're good to go on that. Okay, I'm going to go on down here to number 14. So if you double each side of a triangle, the resulting triangle is similar to the original. So what you're saying is the new triangle, all the sides have a 2-to-1 ratio to the old triangle. So if all the sides have the same ratio, we're back to one of our theorems back here. This is the side similarity theorem, Theorem 55, because if AB, let's see, if AB is twice what DE were, and BC is twice what EF is, and AC is twice what DF is, the ratios are all 2-to-1, and therefore they are similar by side similarity. And that is what you need for this. All right, I hope that was helpful for chapter 8.3.